On this episode of Single Variable Madness, we have to solve x to the power of ln of x equals 2. ln of x refers to the natural log of x. So how do we start with a problem like this? Well, when we have a variable in the exponent over here, usually the best thing to do will be to take the logarithm of both sides. So let's take the logarithm of both sides. So ln of x to the power of ln of x and ln of 2. So then on the left-hand side, you'll have ln of x to the power of ln of x. However, a property for logarithms is that if you have an exponent of, if the value in here, inside the parentheses over here, has an exponent, that exponent can be taken out of the logarithm. So we can rewrite it as ln of x, so ln of x times ln of x. So again, we just took this exponent and brought it down to the left of this ln value, this natural log value. And then the right-hand side is just the natural log of 2. So now what? Well, we have two terms over here, two identical terms, and they're getting multiplied by each other. So by definition, this just means ln of x squared, right? ln of x squared is just ln of x times ln of x. That still equals ln of 2. Now let's take the square root of both sides. Obviously, when you take the square root of ln x squared, you just get ln of x. But on this side, you get plus or minus the square root of the natural log of 2. Remember, this plus or minus is really important. When you're taking the square root of a value, there's always a plus value and a minus value. So always be aware of that. And now we're almost done. Now we just have to bring x by itself. We don't really want this natural log here. So by definition, the natural log of x equaling plus or minus the square root of the natural log of 2 just means that x equals, so remember, if ln of x equals something, then x equals e to the power of that something. So that means x equals e to the power of plus or minus the square root of ln of 2. And then we can rewrite this as two solutions. So there are two solutions here. There's e to the power of positive the square root of ln of 2, and e to the power of the negative square root of the natural log of 2. So two values, and then just to approximate these, this over here is about 2.299, and this over here is about 0.435, and we are done.